Lagrange multipliers is also good for, so it's maximize or minimize, And so like, for example, if we had, let's say we continued this function g around to here, I guess maybe that would have made that. Okay, so that's the closest point. But also you can do it to look for the furthest point away, which might be like this point here, might be the furthest point away from here. And that also, if you draw the corresponding level curve, that's also gonna the black one, the level curve that corresponds to the increasing distances, also has a gradient in that direction, and also the g function also has a gradient in the same direction. Okay, so those gradients are in the same, pointing in the same, both of them pointing in the same direction. Okay, so I just wanted to so it's good for maximizing and minimizing. Okay, so let's look at number 1 from the homework. And here we're supposed to, we have a contour, curve with an equation, g of x equals 8. So g of x equals 8 is this kind of reddish purple thing. And then we have contour maps of f, which are these blue circles or ovals or whatever, or different, I don't know what shape that is. But you're supposed to estimate the maximum and minimum values of f. And so what happens is you look at where these blue things are tangent to this at their minimum point. So the distance, yeah. So you look where these things are going to be tangent to where the blue curves are going to be tangent to the red curves. And we have one right here where it looks like they're both tangent. And this is 30, okay? So this is 30. And then you have over here, they're almost tangent. This is 60, and that's 59. Okay, they're almost tangent, so we can probably say 60 or maybe 59. So let's say maybe this is, maybe this one's at 59. It looks like these are tangent, so this one is at 30. So I would say the minimum is 30 and the maximum maybe 59. 60 might all work for that because it's so close. Okay, so that's just not even knowing anything about the formula for f or the formula for g, but we do know that the graph of g is this red thing here. Okay, and it looks like that's correct. Okay, so number 2, what we're supposed to do here is this function f, we're supposed to find the maximum value and the minimum value subject to this constraint. Okay, so this is our constraint. Okay, so that's our g of xy equals c. So g of xy is this part right here. So this is g. Okay, and then of course that's f. Okay, now once again for the Lagrange multipliers, what we're looking for is like here's our constraint, and then we're going to maximize or minimize f. So you're looking for where the gradients are multiples of each other. Okay, so that means what we're going to do first is we're going to calculate the gradient of f. And what's that going to be?
Oh, shoot. Yeah, sorry, I don't remember.
Oh, the first plot is the partial of this with respect to x.
So it'd be 8x.
It would just be y. So the partial with respect to
Oh,
x,
that, sorry.
and then the second one is partial with respect to y. So you're going to get x. Okay. And then the gradient of g is here. You're going to get the partial with respect to x would be 8x, and then the partial with respect to y is 2y. Okay, so you have yx equals lambda times 8x 2y. That's the condition right there. That's the gradient of f equals a lambda, a constant, times the gradient of g. Okay, so that gives us the following equations. Y equals 8 lambda x, and then x equals 2 lambda y. But then you also have to, you also carry the g of xy equals c. You also carry this one, okay? So you're looking at these three equations, and the solutions to this are going to give you where the maximum and minimum values occur. Okay, so you're looking at those three equations, and you're try to solve those. So, how can we solve those? Well, here we have y equals this, so maybe we can plug that into here. So I'll give you x equals 2 lambda, and then y is 8 lambda x, right? Okay, and then solving this further, we get lambda. Now all this is going to be 16 lambda squared times x, so it's going to be minus 16 lambda squared x equals 0. And then you can factor an x out. And that's telling you that either x equals 0 or lambda is plus or minus 1/4. So 1/4 or negative 1/4. Lambda would be plus or minus 1/4. Or x is 0. Okay. So we have that bit of information there. This is pretty precise. Now, if x is 0, then this one right here, this would imply that y equals 0 also, because y is equal to 8 lambda x. But then 4x squared plus y squared equals 8 is not going to work. Would imply 0 equals 8. Okay, so that's just not going to work at all. So that's not a possibility. So at this point, we have lambda equals plus or minus 1/4. Okay, so now if we say lambda is 1/4, then that gives us y is going to be equal to, what is it here? We put a 1/4 into here, we get, well, it's going to be 8 times 1/4 times x. So y equals 2x. And then this one also, this equation also gives you x equals 2 times 1/4. It also gives you y equals 2x, the same thing. Okay, so we plug that into here. We have 4x squared plus 2x quantity squared. So plug that y equals 2x into here, equals 8. So we have, what is it, 4x squared plus, so 8x squared equals 8. That means x is plus or minus 1. Which means if x is 1, then y is going to be 2 from here. And if x is negative 1, then y will be negative 2. Okay, so we have those two solutions there. Now, if we go lambda equals negative 1/4, then we have y equals negative 2x. Okay, and then when you plug it into here, again, you're going to get 8x squared equals 8, and x is plus or minus 1. So then x being 1 makes y negative 2, and x being negative 1 makes y equals positive 2. So we have 4 different points right there. So let's do this. Those are our candidate points. And we have f of x, y, x times y. Okay, so there's 1, 2, negative 1, negative 2, and then there's 1, negative 2, and then negative 1, 2. Okay, so do you take the product of those two? That's 2, that's 2, that's negative 2, that's negative 2. So the maximum value is going to be 2, and the minimum value is going to be negative 2. Okay, so any questions about any part of that? Okay, let's go on to the next exercise. Okay, so it says this extreme value problem has a solution with both a maximum value and a minimum value. Use Lagrange multipliers to find the extreme values of the function, of this function here, x squared plus y squared plus z squared, subject to the constraint x to the fourth plus y to the fourth plus z to the fourth equals 5. Okay, so again, this right here is our f, and this is our g. Okay. Of course, that's our f, it's labeled f. And so we're supposed to find the extreme values of this, subject to these constraints. And I made a typo here, this should be a 2 there. Okay, yeah, okay. So
we first find the partial derivative in terms of x.
yeah, the gradient of f,
Gradient.
which is going to be 2x and what?
2y and then 2z. Oh, yeah. And then it's going to be 4x to the third, 4y to the third, and 4z to the third.
Okay, so, and then you're gonna solve this equation here. So it's gonna give you 2x equals 4 lambda x cubed, and then 2y equals 4 lambda y cubed, and then 2z equals 4 lambda z cubed. And then we still have this equation here, which is x to the fourth plus y to the fourth plus z to the fourth equals 5. Okay, so carrying this one, if we bring everything to the left-hand side, we can divide by 2. So that would make all these 2's, right? And then bring everything over to the left and factor an x out. We get that, right? I'm doing a lot of stuff in my head. This is probably not a good idea, but I'm doing it anyways because, I don't know, it's fun. Okay, so 1 minus 2 lambda z squared. I think I got that right. Okay, so here, okay, basically all those are equal to 0. So this gives you either x is 0 or x is, actually let's just solve for x squared. X is 0, or x squared is equal to 1 over 2 lambda. Okay, and then this one gives you y equals 0, or y squared equals 1 over 2 lambda. And this one gives you that z is 0, or z squared equals 1 over 2 lambda. Okay, and then of course you have this other condition, x to the fourth plus y to the fourth plus z to the fourth equals 5. Okay, so this problem is kind of tricky because you have an option between 0 and this for each one of these, right? And then you have this, okay? And the solution is like, here's one way that you can do to solve it. Well, if x equals 0, and x can be 0 because that would just zero that out, right? And you still have y and z. So let's split it up into different cases. So case 1, if x and y are both 0, then that means that z squared has to be 1 over 2 lambda, right? And so that means that in this last equation, which we'll call, maybe we'll put a star here, this equation here, that means in that equation, since those are both 0, we're going to have, so we're going to have 0 to the fourth plus 0 to the fourth plus 1 over 2 lambda squared, because this is z squared. Z to the fourth is going to be the square of that, equals 5. We could leave it like that and find lambda, or we could just say that it's probably easier just to say z to the fourth equals. So that means that z squared is the square root of 5. Okay. And in that case, notice I didn't solve for z because it doesn't appear in the f part. So f, in this case, f of x, y, z, which is f of 0, 0, root 5, or the square root of 5. Well, the square root of 5. That's going to be that's going to be 0 plus 0 plus the square root of 5. That's the square root of 5. Okay, so that's a possibility. Then if you look at, then we can go, okay, case 2. Okay, now if we make x and z both 0, and we make y, then y is going to have to be the square root of, y squared is going to have to be the square root of 5. And so that's going to end up being the square root of 5 again, right? And likewise, if we make y and z both equal to 0, and then y squared will be 1 over 2 lambda, and z squared will also be 1 over 2 lambda. That's another possibility that we could do. That's going to yield different results. Okay, so in that case, in this case 2, what's going to happen is when you plug it into this second one right here, you have 0 plus 1 over 2 lambda squared plus 1 over 2 lambda squared equals 5. Okay, so that's going to be 2 times 1 over 4 lambda squared, because there's 2 of them. This is basically 1 over 4 lambda squared equals 5, which gives us 1 over 2 lambda squared equals 5, which gives us 2 lambda squared equals 1 over 5. Lambda squared equals 1 over 10. So lambda is the square root of 1 over 10, which means that y squared is 1 over 2 times the square root of 1 over 10, which means it's the square root of 10 over 4, or the square root of 5 over 2. So y squared is square root of 5 over 2. And then f is going to be 0 plus the square root of 5 over 2 plus the square root of 5 over 2, which is going to be 2 square root of 5 over 2, which is going to be a square root of 10. Wow. Okay, so square root of 10 for this one. Okay, so here so far we got square root of 5 and square root of 10. And now case 3, where they're all, where x squared is 1 over 2 lambda, y squared is 1 over 2 lambda, and z squared is 1 over 2 lambda. So making them all equal to these values instead of making them 0. Okay, and then plugging it into here, we have 1 over 2 lambda squared plus itself 3 times, so that's 3 of them, is going to be equal to 5. So that's 3 over 4 lambda squared equals 5. Let me go all the way up here. So that makes 4 lambda squared over 3 equals 1 over 5. Lambda squared is 3 over 20. Whoa. So lambda is square root of 3 over 20. Okay. So that means that x squared is 1 over 2 times this. That reduces back to 5. So it's the square root of 5 over 3. So x squared, and then y squared and z squared are all equal to this. Okay, so these added together, which is your f, is going to be 3 times the square root of 5 over 3, which ends up being the square root of 15. Okay, and so though you get these 3 possibilities for values, this is the largest and this is the smallest. So that means that this is the maximum value and this is the minimum value right here. Okay, so this maximum value, the square root of 15, and the minimum value, square root of 5. Okay, let's see if Webassign agrees. Yes. Okay, so that was kind of weird because you don't necessarily have to solve for lambda right away. Sometimes, you know, we did it because it helps. Of course, we did it. We found lambda. Also, this is kind of a weird situation. Okay. Any questions about that? Okay, let's go on to number 4. Here, you're supposed to find the extreme values of f on the region described by this inequality. So x squared plus 4 y squared is less than or equal to 1. Okay, now, when you have an inequality, this kind of reverts back to the previous section where you're going to have this inequality describes a region, not just a curve, okay? And so you could have a extreme value inside there, but in this case, it's not going to happen. If you do have a extreme value inside, it's at a critical point. But if you take a look at fx, take the partial with respect to x of f, that's going to be negative y e to the negative xy. And the partial with respect to y is going to be negative x e to the negative xy. And, well, I guess getting those, well, actually, maybe. Okay, I take that back. I totally take that back because 0, 0. So this one's going to tell you that y has to be 0. This tells you that x has to be 0. So this right here is a critical point inside the region. Inside the region. Okay. So this is sort of reverting back to what we did in the previous section. So you have to worry about that. So that means this is a candidate for maximum minimum. Okay, so f of 0, 0 equals e to the 0, which is 1. Okay, so that's something we have to keep. That's a value we have to keep in mind. It could be a minimum or a maximum. Okay, so once you do that, you set that aside. Okay, we'll worry about that later. And you look at this right here. And then this is our G. So your G will be x squared plus 4y squared equals 1. So you just look at the boundary. Okay, so the inside part, this looks like an ellipse. Let's look at the inside of an ellipse. The only point inside this ellipse that might give you a maximum or minimum would be this, would be 0, 0, because that's the only critical point, and that's 1 there. Okay, so now we just have to worry about the boundary. So take the gradient. So that's negative y e to the negative xy, negative x e to the negative xy, and the gradient of g. So what's the gradient of the g part?
It would be 2x and 8y.
Yeah, exactly. 2x and 8y. Okay, great. So we take this one right here, negative. Okay, hold on. Write this differently. Okay, so gradient of f equals lambda times the gradient of g. Okay, that's going to give us negative y e to the negative xy equals 2x. It's also going to give us negative x e to the negative xy. Okay, when we got cut off, we were right here. And so from setting the gradient of f equal to lambda times the gradient of g, we get these two equations, the first two equations. And then the third equation is just the g of xy equals c, this right here. Okay, so if I take equation 1, this equation, and divide by equation 2, then the e to the negative xy's cancel, and I just get y over x on the left-hand side. And on the right-hand side, I get 2x over 8y because the lambdas cancel. So I have, so cross multiplying, I get y squared equals 1 over 4 x squared. I plug this into here. And that gives me x squared plus 4 times this equals 1, which the 4's cancel, and there's 2x squared equals 1. So x squared is 1/2. So that gives me two different values. X is equal to 1 over the square root of 2, and x equals negative 1 over square root of 2. Solving for y, I get y is either plus or minus 1 over 2 root 2. And then here, same thing. So that gives me 4 different possibilities where x is 1 over root 2, 2 possibilities where y is plus or minus 1 over square root of 8. And then 2 other possibilities where x is negative 1 over root 2. The objective function, this one right here, f of xy equals e to the negative xy. For these different values of x and y, it gives me e to the negative 1/4, e to the positive 1/4. Since this is greater, e to the 1/4 is greater than 1, and it's greater than, certainly greater than negative e to the negative 1/4. And then e to the negative 1/4 is less than 1, and it is, then this is then e to the 1/4 is the absolute maximum, e to the negative 1/4 is the absolute minimum.